Hey, this is Nick. We're in chapters 1 and 2 today. We're introducing this concept of what is a server, what do they do, why do we have them, and how do we install or set up a server. And I want to get started talking about that by introducing the peer-to-peer network model. Now, before we had servers, we had this peer-to-peer model, and we also see this peer-to-peer model popping up today in various places. And what this is several computers attached to a network switch, and they can all talk to each other. Typically these days, all these computers can also get on the internet. Now, this is the most common use for a peer-to-peer network model these days is for to allow internet access for multiple computers. But another use for peer-to-peer models, or any network for that matter, is information sharing. Let's say that this computer here has some information that other people need access to. Well, he can share that information, and other people using the computers can access that info across the network. Okay. In this instant, this computer is acting like a server. Okay. At its most basic level, a server is a device on a network that provides a service and responds to requests. So let's look at what's happening here. This guy is sharing files and folders. So he is providing a service called file services. He's acting like a file server. He is also responding to requests. As these computers request the files that he has, he will respond to those requests by serving up whatever file that they ask for. Okay, he is playing the role of a server. Now, let's be careful with this. He's a PC. Okay, he's playing the role of a server does not make him a server. Just like whenever I cook dinner at home, that does not make me a chef. I didn't go to school to be a chef. I am not a chef for a living. I can occasionally step up and cook dinner when needed. Okay, there's a difference. This PC is acting like a server, but he's not a server. He doesn't have the hardware to be a server. He doesn't have the operating system to be a server. Okay, he is simply stepping up and doing what's needed of him at that particular time. And any of these computers can do that very same thing in the network. Any of these computers can step up and be a file server or provide whatever service that is needed at any given time. It does not make them servers either. They can play the role if they so choose. Now, this is a common thing to see among small businesses, especially to have one or two computers in the network sharing a few files and folders. Maybe you have a printer attached to one of these computers, and you share that printer for other people to print to. In that case, that computer is providing print services. He is acting like a print server. Okay. Now, here's the problem with this model. As our business grows, and as more and more data is accumulated in the business, and it's accumulated on various PCs, and the need to share information also grows. And we end up having several PCs with a need to share information. And we end up with a Wild West situation where it's unclear which computer is sharing which information. And it becomes really difficult to maintain and manage this information, especially when you're working with PCs whose hardware is designed to be affordable by the end user. So the hardware is not designed as robustly as server hardware will be designed. So PC hardware is going to fail more often. So you're going to have computer crashes. And when the computers crash, the information they were sharing crashes along with it. and you end up with downtime. Okay, this is a common challenge of small businesses using the peer-to-peer model. So when you get to this point where you're outgrowing the peer-to-peer model, you need something that's going to better serve your needs. And that something is a client-server model. So we have a similar network here on the left-hand side, but instead of all PCs, we have thrown one server into the mix here. And there he is, right there. And if I can get my pointers to work right. Now, this guy's job is to provide services and respond to requests. So all those things that these PCs were doing previously are now his job. So he provides the file services. He provides anything else that these clients will need. Okay. Picture this: my family and I love to go out to eat. Unfortunately, we don't get a chance to do that very often. One of our favorite restaurants is Carino's, the Italian restaurant. Now all we have to do is go in and sit down, and a person comes to take our order, and we give him our order. He disappears to the kitchen, works some magic, and comes back with our food. Okay. In this case, we are the clients. The waiter or waitress will be our server. It is his job to provide services and respond to our requests. Okay. Exactly what this guy's job is: providing services and responding to requests. Now, he could be providing file services. He could be providing a website. He could be providing access to an application or a database of customers. Okay. He could be doing all of those roles all at the same time. Okay. And for small businesses, you see this very often. You see one server providing multiple services because small businesses can really only afford one server. Server hardware is very expensive, so they have to consolidate where they can. Now, when you get on up into the larger businesses, one server isn't enough. You have a lot of requests coming at the servers all at once, and one server can't keep up with all that. You have to distribute that load across multiple servers. So one of these guys could be doing file services, and one guy could be doing print services, and one guy could be doing the website or the applications, what have you. Okay. Now, and in either case, we have a client-server model, whether it is a centralized model, as depicted by the one server, or whether it is a more distributed model, as depicted by the multiple server model. Okay. Now, most small businesses can't afford to have multiple servers in their environment. As I mentioned before, server hardware is very expensive. But that presents a challenge to a lot of small businesses because sometimes you need more than one server, especially in the case where you have an application that cannot be installed alongside other applications that you need. Okay. This is a big challenge to small businesses, and up until recently, it just had to be dealt with just installing the applications side by side and hoping they work. But now we have a way around that, and that way is called virtualization. Now, typically, what we have in most networks is this scenario right here, the traditional architecture scenario, where we have one piece of hardware, and on that hardware you install an operating system like Windows Server. And on that operating system you would have your applications, whatever you happen to be using. Now, let's switch gears for a moment and talk about cars. Okay. If you're like me, you drive to work or to school by yourself and no one rides along with you. Most cars today are made to hold 5 people at least comfortably. So whenever we drive our cars to work or to school with just us, we have 4 empty seats in that car. And quite honestly, it wouldn't be any more stress on the car to put a few more people in there to carry around. So we are essentially underutilizing the space that our car provides to us. And that's what we have most of the time with servers. Even file servers or application servers, they may have a few moments of high activity one or two times throughout the day, but by and large, they're pretty much snoozing. Okay? So instead, we can have this scenario here. Have one piece of hardware, and instead of installing an operating system on that hardware, we would install a hypervisor. And it's the hypervisor's job to control what we call virtual machines or virtual computers. It's a fully functioning computer that lives virtually on top of that hypervisor. Now, inside these virtual computers, we can install operating systems and applications on top of the operating systems. Okay. These operating systems that you install, they are completely oblivious to the fact that they're in a virtual environment. They think that they're the only operating system on that hardware. Each one of these operating systems thinks that. It's the hypervisor's job to make sure it stays that way, to make sure that all these operating systems can coexist and function on the network as 6 or however many separate computers, even though they're living on the same host. So we have our host, we have our hypervisor, we have our virtual machines, these guys here. Okay. This is a very basic picture of virtualization. This is how virtualization works in a nutshell. The hypervisor that provides this virtualization, the most popular hypervisor we have is called VMware. They have one called vSphere, used very often in business. We have a version of VMware on our lab computers. It's not vSphere, it's a more watered down application-based hypervisor. Microsoft has a hypervisor called Hyper-V that's sometimes used, and Citrix has one called XenServer. The one I see the most often is VMware's vSphere. Okay, virtualization, it would do you well to learn all you can about virtualization. The world is going virtual, and if you do not jump in, get your hands dirty with virtualization, you will be left behind, and I don't want that for you. Okay, I highly recommend you take all the classes and learn all you can about virtualization. Pulaski Tech has a class on VMware itself that will be very good for you to take. Now let's talk about servers, specifically server hardware and operating systems. Because of what they do, servers are constantly responding to requests and providing services, and they have to be up for long periods of time. They also have to be able to handle heavy loads. So the hardware of a server has to be robust enough to handle all that. Now, the hardware comes in different designs, or what we call form factors. And the first form factor we're going to talk about is the desktop form factor. It looks like a PC tower. It's bigger than a PC tower, still has all the high quality parts that a server is supposed to have. The desktop form factor is aimed at small and medium-sized businesses that need that robust hardware, but don't need very many servers to run their environment, maybe 1 to 5 servers to run their environment, because these things take up a lot of space. And typically when you have these desktop form factor servers, you have 3 or 4 of them sitting in a server room somewhere, or maybe in someone's office. I've seen that too. Okay, these things take up quite a bit of space on their own. As you get into the larger businesses, the mid-size to small enterprises and things like that, where the company has to purchase hundreds of servers, space becomes an issue. And you need servers that take up less space but still have the same horsepower and the same robustness of hardware. That's where the rack mounts come in. These are designed to be installed in server racks that are placed in server rooms or in data centers. Okay. Now, the last form factor we'll talk about is a blade form factor. These are aimed at the high-end businesses, the very, very large businesses that need thousands of servers and need to maximize the space in which they put those servers. Now, these are also designed to go into server racks. But in the space where only 2 or 3 of these rack mounts would fit, you can fit, how many is this? 8 or 9 servers. So this will maximize even more the space that we have in our data center racks. A very expensive form factor, by the way. Now, the hardware is just half the puzzle. I can install Windows 7 on one of these rack mount servers and still all I have is a very expensive desktop computer. Okay. The other piece of the puzzle is the operating system. The combination of hardware and operating system is what really makes it a server. And the people who make these operating systems are people like Microsoft and Linux and Unix and IBM and Novell. And I threw Apple in there for good measure. In this course, we're going to be focusing mainly on the Microsoft servers. Now let's have a look at the entertaining and historically inaccurate account of Microsoft's history in the server business. We started back in 1993 when they released Windows NT Server, and they went through various flavors of that. Then it came out with Windows 2000 Server and stepped on up through 2003s and the 2008s and most recently Windows 2012 Server. Now this course is going to be focusing mainly on the Windows 2008 R2 server. And I know what you're thinking, why aren't we talking about Windows 2012 server? Well, the answer to that question is this course is based around the latest industry standard operating system. And even though Windows 2012 is out and being used right now, it has not been widely adopted enough to be considered an industry standard. Windows 2008 R2 has that designation right now. So our efforts will be focused on that version, the Windows 2008 R2. And we have several flavors or edition of 2008 R2, starting with the nuts and bolts foundation, aimed at very small businesses, only has a few server roles available for use, and the price point is very low to be affordable by the small business. Next up is Standard Edition. This has most of the server roles available for use, and it's aimed at a small to medium-sized business. Now, the Enterprise Edition is significant because it is the lowest edition of Windows 2008 R2 where all of the server roles are available for use. We're also adding more features for high availability. We'll discuss that later on in the semester. And we are adding some hardware features as well that the Standard Edition did not offer. Now, the Data Center Edition of Windows 2008 R2 is an OEM. It's a special edition of Windows called OEM. What that means is that you can't just walk into a store and buy a license of Data Center. Data Center comes pre-installed on only approved hardware. The next edition of Windows is Windows Web Server, designed to be a web server, host websites, and that's really it. Finally, we have the Itanium-based systems edition. This is designed for hardware running Itanium processors. Now, in this course, we'll be focusing on the Enterprise edition of Windows 2008 R2, mainly because it is the lowest edition that has all of the server roles available for use. Now, our next video is going to be a demo installing the operating system and what to do with it once we get it installed. I will see you then.